Hello, welcome to Astronautics for Exploit. This is Dr. Ayanshola Ogundele. Multi-orbit satellite constellation, a unified communication network of satellites in LEO, MEO and GEO. Multi-orbit satellite constellation, a hybrid space architecture, which combines satellites in different orbits, such as low Earth orbit, medium Earth orbit, and geostationary Earth orbit, leverages the distinct advantages of each orbit, such as LEO for lower latency, MEO for global navigation, and GEO for wide area coverage, in order to meet diverse connectivity needs for applications such as video calls, cloud computing, and in-flight internet. Migration to the multi-orbit satellite constellation is necessitated based on its various advantages, such as latency reduction, expanded coverage, increase in resilience and reliability, and intelligent traffic routing. These satellites provide the lowest latency for applications, where every millisecond is critical, while geosatellites offer reliable high-bandwidth services that are not sensitive to delay. LEO constellations are constantly in motion, filling coverage gaps over polar regions and oceans that are out of range for fixed-position geosatellites. This results in truly global connectivity. By leveraging multiple orbits, a hybrid network avoids relying on a single system. If one satellite or even an entire orbit is compromised by space weather, interference, or equipment failure, traffic can be rerouted to another network. This redundancy is a major advantage for mission-critical applications in government and defense. Multi-orbit satellite constellations have their challenges, such as ground segment limitations, complex ground management, regulatory landscape, and a host of others. Despite the challenges, multi-orbit satellite constellation systems are seen as the future of connectivity. The focus points are as follows: GEO versus MEO versus LEO satellite constellation, multi-orbit satellite constellation, working principle of multi-orbit satellite constellation, and challenges of multi-orbit constellation. GEO versus MEO versus LEO satellite constellation. Satellite constellations in geostationary Earth orbit, medium Earth orbit, and low Earth orbit primarily differ in their altitude, coverage area, latency, orbital period, and the number of satellites required to provide continuous service. Illustration of low Earth orbit satellite constellation is shown in this picture. Satellite constellations comparison, proximity and latency. LEO satellites are closest to Earth, resulting in lowest latency, making them suitable for real-time two-way communication, such as video calls and online gaming. GEO satellites are farthest, leading to the highest latency, which is acceptable for one-way broadcasting applications, such as satellite TV. MEO offers a middle ground. Illustration of low Earth orbit, medium Earth orbit, geostationary Earth orbit is shown in this picture. Movement and coverage. A single GEO satellite can provide continuous coverage over a large fixed area because its orbit is synchronized with the Earth's rotation, appearing stationary in the sky. LEO and MEO satellites move quickly relative to the ground, and these thereby require large constellations and complex ground station tracking in order to ensure continuous uninterrupted coverage. Satellite low Earth orbit constellation is shown in this picture. Cost and complexity. LEO satellites are typically smaller and less expensive to build and launch, though the need for a large constellation and a more complex ground system can increase overall network costs. GEO satellites are larger, more powerful, and more expensive to deploy into their high orbits. LEO satellites offer better signal strength and less propagation loss due to their proximity to the Earth, while MEO and GEO satellites require more powerful transmitters and larger antennas to bridge the greater distance. Telesat Lightspeed constellation is shown in this picture. Multi-orbit satellite constellations is a network that integrates satellites from different orbits such as LEO, MEO, and GEO in order to provide resilient, flexible, and high-performance connectivity. Multiple A multi-orbit satellite constellation approach allows users to leverage the best characteristics of each of the orbit. Eutelsat multi-orbit GEO satellite is shown in this picture. Multi-orbit satellite constellation characteristics are as follows. Ability to switch between different networks and satellites in case of congestion or satellite failure. Using multi-orbit constellation, different applications can be routed to the most suitable orbit, optimizing performance based on the unique demands. It provides comprehensive coverage, including difficult-to-reach areas such as polar regions, which can be challenging for single-orbit systems. Illustration of satellite coverage for telecommunication services is shown in this picture. Working principle of multi-orbit satellite constellation. A multi-orbit system dynamically routes user traffic to the most appropriate satellite network based on real-time needs like latency, required bandwidth, and location. This is often facilitated by advanced ground infrastructure and user terminals. Orbital design optimization for large-scale SAR constellation is shown in this picture. LEO might handle latency-sensitive traffic like interactive data and voice calls. GEO might manage high bandwidth, one-way data broadcasting, such as streaming video, or serve as a backhaul for fast remote areas. And MEO can provide a reliable middle ground for specific enterprise or government applications. Satellite's multi-orbit ambitions is shown in this picture. Challenges of multi-orbit constellation. User terminal complexity and cost. A key challenge is developing cost-effective user terminals which can seamlessly connect to and track satellites across different orbits. Network orchestration. Managing the complex handovers and dynamic routing of traffic between fast-moving LEO satellites and fixed GEO satellites in return is a significant technical challenge. And addressing policy challenges and streamlining spectral access for different systems can be complex. In-orbit target-based autonomy for enhanced stability of small satellite constellation is shown in this system. Other challenges are resilience, which require diversity. For truly robust service, resilience does not come from a single multi-orbit terminal alone. To eliminate single points of failure, there is the need to have multiple terminals connected to different networks, and this will help to achieve a higher reliability. Integrating signals with different latencies and performance characteristics into a single software-defined network remains a significant technical challenge. Illustration of the use of artificial intelligence in transforming geospatial intelligence is shown in this picture. For more information, contact Astronautics for Exploits. You've been listening to Multi-Orbit Satellite Constellation, a unified communication network of satellites in LEO, MEO, and GEO. Presented by Dr. Ayenshola Ogundele, with the focus point GEO versus MEO versus LEO satellite constellation, multi-orbit satellite constellation, working principle of multi-orbit satellite constellation, and challenges of multi-orbit satellite constellation. Thank you.